Podcast is now starting. All attendees are in listen-only mode.
Good afternoon. Welcome to Eccentric Mold and Engineering's webinar. If you're here for designing for manufacturability, you're in the right place. I'm Connie, and I'll be your host for this session. A few things to cover before I turn over the webinar to our keynote speakers. This presentation will expected to last approximately 30 minutes. Q&A is included, so during the presentation, feel free to submit your questions to us, and we'll answer as many as we can. And that is located on the chat function in the lower right-hand corner of the control panel. With that, now I'll turn over our webinar to our two keynote speakers, John Sidorowitz and Glenn Miller. Gentlemen, please tell us a little bit about yourself.
Thank you, Connie. My name is John Sidorowitz. I am VP of Inside Sales here at Eccentric. Glenn?
Glenn Miller, Senior Tooling Engineer here at Eccentric Mold.
All right, well, I just want to thank you, everyone, for joining this afternoon. We'll just jump right into things here. Again, just feel free to submit questions throughout the presentation, and we'll get to those at the end. So, why choose injection molding? We list a few reasons here, mainly design integrity, part tolerances. If you have parts with tight tolerances that you need to repeat high volumes, form, fit, function, your iteration cycle, scaling up production, and then even moving prototype to production, and then lastly, time to market. So, Glenn, something you want to jump on?
Per the slide, efficient tooling, it's basically a culmination of different things, a good part design, as well as using mold flows and other aspects to try to make the best possible mold to produce the part, the right material flow, cooling, and all of those features as a complete package.
Yeah, and for those not 100% familiar with injection molding, with the process, you have two halves of the tool. Your core, which is often referred to your B half, and then your cavity or your show side, referred to the A half. So when those come together, plastic shoots in via sprue runner gate. The cavities fill with plastic, and the mold opens, and parts fall out. So kind of got an illustration in the middle of the page there, kind of explaining that if you're not familiar with the process. So probably first thing before even designing your part is your material, considering what environment this part is going to be in, how it's going to function, what it's going to, the performance of the part, and obviously cost of the material, because that's all going to play a role in your design as well, even coming down to wall thickness, if you're getting into overmolding, insert molding, and that type of stuff as well.
And each material has its own properties that are better for certain applications, whether it's rigidity or whether it's flexibility, strength.
Viscosity versus.
It also affects the fill and flow of the material through the tools. So a lot of times certain materials rely on a certain wall thickness in order to flow properly. So all that needs to be considered when you're looking at materials for your part.
Yeah, and if you're not sure what type of material you need to go with or need help, we can help with that by referring you to one of our many material houses and get you in touch with a materials engineer. Tight tolerances, unfortunately, this is a term that's kind of thrown about. So if you don't perform this correctly within the tool or in your part design, a tight tolerance can lead to a loss in performance or even part failure. To keep in mind when you're dealing with critical features or areas with tight tolerances is to stay away from high shrink materials and focus on low shrink materials like ABS or glass filled materials. Avoid tight tolerances around areas where where the mold halves come together at the parting line, or where you're gonna have moving components like slides or hand loaded actions on your part.
Anywhere you're going to see a seam, anywhere you're going to have adjoining pieces come together, you want to make sure that you have a little bit of room for the tolerance on the tool itself.
And again, avoid areas that are going to be prone to, warp or distortion on the part, unsupported walls or areas like that.
Any kind of long flat piece without any type of structural support is definitely going to cause you issues with warpage and things like that. So that's something you definitely need to consider with your design.
Do you want to?
A huge factor in part design, we see this a lot. Wall thickness, whether it's the main wall thickness of your part or adjoining ribs, other features, bosses, you have to try to maintain a certain percentage of wall thickness so that you don't get thick areas in your parts. It can lead to things like sink and so forth, which we'll discuss a little bit later.
And just some notes there, a 10% increase in wall thickness will provide approximately a 33% increase in stiffness with most materials. Stay away from thick sections of material. Try to core those out. It's only going to help part cost, but also processing your part, avoid sink, warp, amongst other things. And then the use of ribs or stiffening features in the absence of those thick sections will help stiffen up or add that strength back into the part.
Right, rather than a thick section of wall, a smaller gusset rib will provide the same structural integrity to the part.
So draft. So you want to design your part with draft, and that's going to help prevent the part sticking, mainly to the core, but it can also cause your part to stick into the front half of the tool, which you don't want. There's really no way to eject off. Typically, we would want at least a half a degree of draft in most parts. Most of the time, 1.5 to 2 degrees per side are standard. And if you're going to be looking at textures, any type of like media blast or texture, you're going to want at least a 3-degree draft angle on the side walls, and this is going to prevent drag markings on the outside. So when the mold does open, it doesn't basically scrape across the outside surface of the part, because with the texture, you're essentially creating hundreds and hundreds of micro little undercuts.
And it really depends on the overall depth of the feature as well. Depending on how deep that part is, you may be able to get away with slightly less draft, but zero draft is never your friend when it comes to injection molding a part. As John said, you have a lot of issues with drag features and scratches on parts and ribs and inside walls, especially show sides. Anytime you have a texture on there, as he said, you need a certain amount of draft. Certain heavier textures and stipples require anywhere up to 5, maybe even 7 degrees of draft. So it's just something you need to consider in your design.
Okay. And that again applies to outside and inside of the part, as you kind of see in the illustration. So the runner system is kind of made up of 3 things. You have your sprue, so that's where the plastic is entering into the mold, and that feeds into the runner system, which then feeds the gate, and that's the entrance into the part. We mainly do edge gates here, so it's an exterior gate. You will see a gate vestige on the exterior of the part. There are many types of gates out there, and we also do them. You can subgate into parts to get the gate vestige off the show surface. Hot tips, cashew gates.
We try to keep the gate minimal diameter to fill the size of the part, and only increase that as necessary if we're running into fill issues. So the overall goal is to leave the smallest amount of vestige possible.
Correct. But yeah, there will be some sort of cosmetic marking on the part.
And hot tips and actuated delivery systems and tools will help with the vestige. They're much cleaner, a little more expensive to design into your tool, requires a slightly larger tool. That's also just something to consider when you're looking at the aesthetics of your part. Next, ribs. A lot of times, before we talked about flat parts and warpage, a lot of times customers require some stiffening features for structure. We like to add ribs. Ribs can be added in multiple ways. You'd like to minimize the overall depth of the ribs. You like to have a good enough draft on those ribs, of course, as with any other feature. Sometimes you can go with smaller ribs and more of them. You can use gusset type ribs that only adjoin two walls on an angle and still get the same amount of structure. An overall rule of thumb with designing ribs into a plastic part is to go no more than 60% of the nominal wall thickness of your part. That helps reduce sink. It possibly won't eliminate it, but it will minimize that. Different types of materials, you can go a little thinner, but you do have to maintain a percentage of the nominal wall, otherwise the sink will become an issue for you, and it can't always be processed at the press.
Yeah, and to touch on like glossy materials, you want to go a little bit thinner because you will get what's kind of called bleed through. You will see the rib kind of bleeding through to the show side of the part, even though it's not sinking or anything like that. So the thinner rib you can go, especially with glossy materials, the better. So bosses are going to be similar to ribbing. So just and bosses are typically going to be used for locating holes, mounting, assembly, and again, keeping in mind the wall thickness, the height. Those are going to be your two biggest factors. How you tie them into the outside walls. As you can see in the images, we've got some examples there of what not to do and a well-designed boss that's in a corner. Again, wall thickness around a boss design feature should be 60% of the nominal wall thickness or the adjoining wall that it's attached to.
Right, and you can get the same amount of strength and the same amount of rigidity with that image on the right that has a boss with two ribs that lock into the two side walls. That is going to provide you the same amount of strength, and you're not going to get that mass of plastic there that's going to cause you all sorts of cosmetic issues, sink and so forth. And it a lot of times trying to get rid of sink requires packing out of the tool, which can lead to other issues like sticking of your part and deformation of your part as it ejects. There's all sorts of reasons, but you do want to follow basically that 60% of the nominal part thickness as a general rule of thumb when designing parts.
And just to add, the height of the boss should never be more than 2.5 times the diameter of the hole within that boss. Corners, so transitions. If you have sharp corners within your part, it can create stress from the resin flow within the part. So you want to minimize that by adding rads to corners. It's also going to help maintain a consistent wall thickness throughout the part instead of going from thin to thick sections and then back to thin. So it will help with fill, warp, and everything else.
Plastic does not like sharp 90-degree turns. It needs a nice smooth flow. Anywhere you can add radiuses or even so much as break corners in certain sharp corner areas at least will help with the flow of the plastic, and it provides a little more rigidity. And as John said, eliminates potential for stress at that area.
Yeah, and I mean, obviously, you're going to have to have a transition once in a while. So some examples of doing that from a thick to thin or thin to thick, thick to thin. There are examples down there. Overmolding. So this is pretty popular nowadays. So we basically take a first shot plastic part, which we call the substrate, and then load that into another tool and overmold that and end up with a finished part, kind of you see on the right there. So by doing this, you can accomplish quite a few things. You can there's a wider range of materials that's available to do that, including both hard and soft plastics. So you can provide a soft grip surface, add flexibility to a rigid part in certain areas, eliminate assemblies.
color contrast.
Yep. Capture another part with inside of another part without having to use fasteners and adhesives. And with that, you have to keep in mind for your design and materials, chemical bonds and mechanical bonds or mechanical holds within that. So kind of in the bottom left corner there, we have those little windows within the part. And what those are for is the material to kind of flow through and lock into the part so it doesn't peel off or fall off in use.
Always a good idea to get the material representatives involved. Certain materials don't bond well to other plastics, so it's always a good idea to get your design in front of a plastics supplier to make sure that we're using the proper resins to bond to the substrates.
Insert molding, similar to overmolding, but typically it's a brass or stainless steel insert or some sort of metal insert being loaded into the mold and basically molding plastic around it.
And that can be anything from, as John said, threaded inserts, circuit boards, anything that they want to have embedded into parts that they don't want to have to put a fastener in to attach it. That way you can run this tool. It does take a slightly longer cycle time as you have somebody loading all of these inserts into the tool. The tool is designed slightly differently to hold those parts in position so the injection pressure doesn't move them around. There's all sorts of things to consider when you're talking about overmolding metal inserts.
Yeah, and the big thing with insert molding is consistency within the inserts. Because usually when the mold's manufactured, we're test fitting those inserts into the mold. So if you have a piece that you need overmolded, that's very loose tolerances, that can cause issues like flashing. The metal insert may not fit or be in the right spot every time. So really tight tolerances are required on those inserts. Undercuts. So an undercut is really any indentation or protrusion that prohibits the part from ejecting from the mold. And these require either an action, a lifter, a slide, hand load, or something like that. So just when you're designing your part, try to consider removing as many undercuts as you can. There's a lot of ways to kind of cheat those undercuts. We give a couple examples here on how to do that. But
I know a lot of times, a whole feature, you can sometimes make, as John said, make some slight adjustments to the draft where we can come from the cavity and core and have an elliptical shutoff that'll create a hole. It does require some extra thought in your design, or you're going to have the tool designer coming back to you for updates and changes to your part design in order to make it toolable.
Yeah, and I mean, adding undercuts is going to add cost not only to tooling but parts. So just try to keep that in mind. And we'll be happy to review your parts here and give some pointers to see what we can do to help eliminate or minimize them. I think that kind of finishes everything off. So we'll kind of go through this checklist here. It's a quick, easy, checklist to have maybe at your desk, and we will send this out. But we can kind of go through each thing. Resins and materials, you try to stick to standard colors or standard off-the-shelf materials. Try not to get anything, exotic or out there. It just leads to it can be costly and run into lead time issues, especially at low volumes. And again, before you start designing, try to narrow down your materials, comparing the price of materials.
Shrink rates, all of that,
Right.
that would be involved in your part.
But yeah, try not to make a selection based on price alone, because you can go with a really cheap material, but it may not perform the way you need. Wall thickness, again, maintaining a uniform wall thickness throughout the part. Utilize ribs to reinforce walls. Core out unneeded thick areas. And just the rule of thumb, a 10% increase in thickness will increase your part stiffness by 33%.
Always keep an eye on your draft. Draft is your friend. You want this part to come out of the tool. No 0 degree walls, depending on the depth of the part. Definitely need that 1/2 degree minimum draft angle. And as a mold designer, mold builder, we always like to see more. But we want your part to be what you need and to perform right. So that's definitely something to consider while you're designing that part.
And again, tight tolerances, try to stick to low shrink materials. Try not to have critical features in areas that might warp or near the parting line.
Your ribs and your bosses, again, really comes down to try and avoid any cosmetic issues, sink. Try to maintain no more than 60% of your adjoining wall, the nominal wall thickness. That's your starting point. We can always add more ribs, add more structure, but you want to maintain that nominal wall thickness and less, so we don't have issues with sink and any kind of cosmetic problems.
Yep. And undercuts, again, just keep in mind they're going to add to the cost of the mold and part price. Try to minimize where you can. Otherwise, there's really no limits with us. We'll find a way to make them happen.
Absolutely. Your corners and your transitions, again, the material does not like to flow around 90 degree corners. Anytime you can have radiuses or a more gradual flow to your part design, when possible. Sometimes that's not possible, but anytime you can add radiuses, chamfers, anything to help with the flow of the material, that will help us in the end.
Okay, we're going to open up to question and answers, and we do have a few. So the first one, could draft be on 3 of 4 sides?
Yes. I'm assuming we're maybe talking a box. Yes, it is possible to have 0 draft on one side, depending what's on that side. If it's critical, it may have to be an action, like a slide or a hand load, to create that face.
How deep is that face?
Yeah, but it is possible.
Yes.
Will we get the slideshow emailed to us? Yes, we will email it to you. I have a thin wall part. What cost-effective plastic would minimize warpage and add flexibility?
It's going to be tough to say without seeing the actual design. You can submit your file through our website for quote, and we can definitely take a look at it. Typically thin-walled materials, polypros.
Polypros, definitely.
But with those, you get warp. There's pros and cons to each. So not knowing exactly what the part's function is, it's going to be difficult to answer that.
Can I overmold 2 rigid materials together?
Yeah, it's really going to depend on the mold temperature needed for the second material or the overmold. Excuse me. It shouldn't exceed the melt temperature of the substrate. So, if that second material runs a lot hotter than the melting temperature of your first shot, it could deform it, distort it, and not have a good part.
Could you please elaborate more on the boss height to diameter ratio?
You basically want to look at 2.5 times maximum of the height of the boss as compared to the ID of the boss. That's just your standard rule of thumb. Whatever diameter your boss is, you don't want to go any more than 2.5 times. Depending on the application, we can stray a little bit from that, but that's your good general rule of thumb.
What are some ways to prevent cracking on plastic?
It's usually stressed.
Well, again, that goes back to no sharp corners, rib features, anything that can be stressed or distorted. You'll see that telltale white stress mark. Anytime you can add a radius or a chamfer to strengthen that area.
Okay, and our last question for this afternoon. What type of insert should be used for insert molding?
Like we'd mentioned, both metal and plastic are available. Mainly we work with the metal, stainless steel or brass threaded inserts. That's a majority of what we do. But yeah, it really comes down to the need of the project.
Okay. Thank you for joining our webinar today. For any questions or interest in Eccentric products, please visit us on our website, social channels, or contact us directly at the number and email listed below. Feel free to contact us any other time. We are happy to help you. Thank you for joining us today, and we hope you have a great day.
Thank you.
Thanks, guys.